Can you hear me? Microphone working? Everyone at the back here? So I want to start off by saying I'm hugely sorry to everyone that's crammed at the back, everyone that's sitting on the floor. Like, there's a lot of bin packing jokes that apply to this scenario. So huge apologies to everyone who's crammed in. That's on us, and sorry.
We need a bigger room.
We need a bigger room. Yeah, or like rooms that can auto-scale. If there's a startup anywhere here that I would help with VC funding there. Okay, so this is the ECS deep dive session. My name's Paul Maddox. I'm a specialist solutions architect at AWS. My official job title is Developer Technologies, which kind of means a mix of serverless, containers, CI/CD, etc. And I've quite an interesting job. I might be a bit biased, but I work with everything from tiny startups to huge enterprises and work with development teams to help optimize development on the cloud. So a bit of background about me, 16 years of experience in the industry. Started off as a software developer developing PHP, but don't judge me. So I started off as a developer, got fed up of fixing other people's bugs, basically, and decided I wanted to travel the world a bit, and so I got into the operations side, ran an ops team, an SRE team for a while, and then decided actually I wanted to talk about this stuff rather than doing this stuff anymore, so I became an architect. Yeah. So that's a bit of background about me. Until very recently, I could proudly say I held all 7 AWS certifications. We've just added the security specialist one, and now I've got that tough decision of, do I want to go and do that just so I can say I've got them all? I don't know yet. So yeah, I'm still an active developer, always a software engineer at heart. I do a lot of development these days in Go. Also some other stuff in like Java and C and Node where I can't use those. So my contact details here, Twitter, email. If you have any questions around containers, serverless, etc., feel free to reach out to me there. The slides are going to be shared. My contact details will be back up at the end. So what are we going to cover today? So these Builder Days events, the brief that we got as presenters and speakers was, don't make this a session that's full of marketing slides. And I was like, yeah, we're going to get deep. I'm actually going to, rather than walk you through all the individual features of ECS one by one and sort of droll on like that, I'm actually going to turn this around and talk about a use case. So we're going to build an application, a microservices architecture together today for analyzing Twitter streams. It's just the first use case that came to mind. We're going to build a couple of microservices that collect a stream of tweets from Twitter and then process them. So using Go, using RPC between microservices, and using a couple of other AWS services like Parameter Store for secrets management and Kinesis Firehose for sort of batching those tweets. During the process of talking through this, my goal here is that by the end of this talk, you understand and know how to, at least the first steps towards all of these things. So how best to deploy ECS? What about monitoring, maintaining availability? What about things like cost optimization and making sure your workloads are as cost efficient as possible, but can also scale efficiently and securely? What are the best practices around security? And then things like monitoring and logging and that kind of stuff. So the kind of, what do I need to take a container from my dev laptop to production with ECS? And that's my goal, to convey that across today. So if you have questions, by the way, we'll try and do Q&A again at the end. We'll just save a bit of time at the end for Q&A. If you do have an urgent burning question, put your hand up and we'll try and get a microphone to you. So I did say this was going to be a deep dive session. I need to spend like 2 minutes baselining on some common terms that we're going to use. So if you're using ECS already today, apologies, this will be over quickly. If you're new to ECS, this might be quite useful. So ECS itself is a container orchestration and management system. You feed it in task definitions. And a task definition is a JSON document that says, OK, I've got these containers. They make up my application. You submit that in to ECS. And ECS is going to look across your various clusters of container instances and say, OK, where can I fit this in? Where can I fit this container in? Where can I run it? That respects all of the scheduling conditions that might be set, like maybe it needs a GPU, or maybe it must run on Windows, that kind of stuff. It's going to schedule that container on one of your container instances. And optionally, if it's a long-running service, it's going to keep it there and keep it running and keep it highly available, like in a self-healing manner. So what are these container instances at the bottom? These are just EC2 hosts. These are Windows or Linux machines in your control. You deploy them, you maintain, manage, and operate them. And we give you some nice tooling to help you do that. But ultimately, these are just EC2 instances. The actual backplane of the ECS system, the ECS Container Service here, this is free. This is something we provide for free. The whole container scheduling orchestration. It's a huge multi-tenant container orchestration backplane. So you don't need to worry around scaling, etc. You've also got the container registry here. Really, really easy, convenient place to put your containers, your container images once they've been built. We're going to talk through all these in more and more detail, but I just want to give you a bird's eye view of how it all fitted together and some of the terminology. How does Fargate fit into this? Fargate kind of sits down here in the architecture. So Fargate is a deployment option where you can take your task definition, and when you deploy it using ECS, you can say deploy to Fargate or to an EC2 container instance. So that's kind of how Fargate fits into this picture. Abby's going to be deep diving on Fargate later today. So one of the questions that comes up a lot when you first start working with ECS is, where's the boundary of shared responsibility? At AWS, we talk a lot about shared responsibility. So normally, if you're looking at something like EC2, we talk about how AWS is responsible for operations of the cloud, but you're responsible for the operations in the cloud and the security of the applications that you run in the cloud. It's the shared model of responsibility. So I want to talk through these core components of ECS and just highlight some of the tasks that sit on our side of the fence that we manage and carry the pager for, and some of the things that you'll need to do as a customer. So starting off with ECS, the actual container orchestration backplane. This is a managed service. It's a free service. You only pay for the container instances, the EC2 hosts. And we're taking care of the security of the service, the monitoring, the patching, the availability, the scaling, and the cost control. That's all on us. As a customer, all you need to do is deploy your cluster. So that could be as simple as a command line script, just AWS ECS create cluster, or you could do that via cloud formation or automation. We're going to talk through a load of options there when we start talking about deployment. ECR, our managed container registry. We're going to be looking after the monitoring, availability, scaling, and patching of the registry, right? So you're not going to have to worry about how do I run my container registry in a highly available fashion. We're automatically going to be scaling it for you. We're going to be worrying about the availability for you, etc. There are still some things that you need to take care of here. So when you put your container images into ECR, you're probably going to need some automation in place to put those container images in there whenever you build one. So something like AWS Code Pipeline. You're probably going to want to think a bit about cost control, especially if you're building lots and lots of container images. You don't want to get into the scenario where you're keeping every single image, every single version, etc. if you're doing like thousands or hundreds of builds a day, right? That's going to rack up costs very quickly. So there are some building blocks that we provide within ECR, things like lifecycle policies. So you could say auto-delete any untagged container images that are older than 30 days, for example. So a lot of these bits at the bottom here on the customer's responsibility side, we do provide building blocks to help you. The container instances, the actual EC2 instances that run your containers, this is where that division really starts to shift over to your side. And one of our main motivations for building Fargate is because today, if you want to deploy an ECS cluster with EC2 instances to run your containers, you need to worry about deploying those container instances yourselves, right? You need to think about how do I deploy those, how do I do cost control, patching, monitoring, blah, blah, blah. There's quite a bit on the customer side there. So the good news is there's a whole load of building blocks in the AWS platform that actually make this easy for you. Things like auto-scaling groups are going to help you with scaling in and out your container instances. They're going to take care of the availability. If one of them dies, the auto-scaling group is going to automatically bring it back up again. Security, you've got tools like IAM and Amazon Inspector that can do automated vulnerability scans on your container instances. So a lot of these building blocks are there for you. And we have some pretty good prescriptive advice that I'll share with you later on each of these things. Ultimately, though, this is what Fargate solves. This, when you're running Fargate, a lot of this goes away. The final component is tasks and containers. So these are the actual containers and images that you need to run on AWS. And ECS is going to take care of deployment of them for you. So it's going to do things like an automatic zero downtime rolling update to your images that are running on the platform. It's going to take care of actually taking the container from the registry, getting it onto the EC2 instance, running it, making sure that the availability stays up. If you select it to be a long-running service in ECS, if a container crashes or dies or blows its heap space, your application or something, then ECS is automatically going to restart it. And you get these nice self-healing architectures that means wherever possible, you're not going to get woken up in the middle of the night. There are still a few things you need to think about. So scaling of your containers. How many of your containers do you want running at any one time? What's your scaling metric? Is it CPU, memory, etc.? And that's normally dependent on the application. You have things like logging. I'm going to show you some nice patterns for getting automatic centralized logging in a minute. Security. This is something that not enough customers ask me about, to be frank. Right? The security of what's inside your container images. So we're going to talk through some best practices there that you can put in place in your CI/CD pipelines, etc., to do things like vulnerability scanning inside your containers. And then patching of your containers. Obviously, you're the one building your containers. Okay, so let's start talking through a few of these best practices, and then we'll start building an application and deploying it onto AWS. So the first thing that you need to do when starting with ECS is deploy your cluster. So how should you do this? And there's a number of ways, because, hey, we like to be flexible. The first one is to use the AWS Management Console. This is a really, really good way of learning about ECS. Right? You can go and get a visual wizard, and it will help you create your first cluster. And you can do things like, do I want on-demand pricing or spot fleet pricing, et cetera? I can choose how many instances I want in my cluster, what instance size, how much CPU and memory, et cetera. So this does make it really, really easy to get a cluster up and running. If you're running in production, you're probably going to want multiple environments, like multiple clusters, one for development, one for production, et cetera. If someone comes up to you and says, hey, we need a new test cluster, you probably don't want to be doing this all by hand, right? Human error, lack of repeatability, et cetera, et cetera. So you want to automate this, right? AWS is API CLI driven. How should I do this? So one approach, and if you've got a Linux background like myself, you think you're the king of the bash one-liners, okay, I'm going to script this. I'm going to write a bash script, and it's going to deploy my whole environment for me. So there's a really, really rubbish example. Don't use this code. Like, I threw this together on a train. It probably doesn't even run. So for a lot of people, scripting this kind of stuff is kind of the de facto, I'm going to go and script this, like, next stage. There's a number of fundamental problems with this that I want to try and help you avoid if you're thinking of taking this route. Number one is, what happens if your script that deploys your whole environment fails halfway through? Are you really going to put safety checks in at every stage of your script? What if an API call to AWS fails for whatever reason? You lose connectivity halfway through, et cetera. How do you get out of that scenario? How do you revert back from that scenario when you're in a half-broken, half-working state? Some API calls in AWS are asynchronous. Things like creating an instance. When you run an instance, the CLI is going to return immediately to you. That instance isn't actually going to be booted up for a couple of minutes or a couple of seconds or minutes, whatever it is. So how do you deal with that? Do you just throw a wait or a sleep into your script? If so, how long for, right? And then once you've got your script working and it's the most beautiful script ever and oh my goodness, we're DevOps, how do you then move on? How do you get on to the next version of your architecture and infrastructure? Do you write an update script that updates it from your old version to your new version? What if I want to skip 3 versions? This is a hard problem to solve with scripting. So I don't recommend attacking this with scripting yourself. Instead, have a step back and think about what we want from deployments. Ultimately, in most cases, we want a self-contained deployable unit. Something that I can just cookie-cutter deploy over and over again and repeat. Something that when someone comes up to me and says, hey, we need 10 new environments, I don't go, oh my goodness, that's a month's worth of work, thank you. We want something that's auditable. So as an organization, I probably want to know which environments I've got at any point in time. when they were spun up, who they were spun up by, how do I find out the owner, etc. And ideally, I want my deployments to be self-documenting. I speak to far too many customers who have Excel spreadsheets of subnets and IP ranges or wiki pages on Confluence or something, or other wiki brands apply. So the trouble with that is, as we all know, they get out of date almost immediately, right? And they're useless to everyone then. So this is where things like infrastructure as code come in. Hands up if you're using CloudFormation or Terraform today. Okay. Most of the room, but not enough. So this is an example of a CloudFormation script. It allows you to define pretty much any AWS architecture, right? Subnets, load balancers, containers, etc., in a JSON or YAML format. What this means is you can take your whole architecture, your infrastructure definition, and put it in a template in your source code repo. Right? You can have version control on your architecture. You can go back to any point in time and say, okay, we had an outage that day. I can see the day before Bob added a firewall rule, security group rule. Let's go find Bob, but not too much because we're a blameless culture. So when you have a CloudFormation template, for example, for deploying an ECS environment, you can just run AWS CloudFormation create stack, or use the AWS console, management console, and deploy this template over and over again. And you can just give it a stack name, like pre-production in this case, and then point it at the template file. It's going to go away, and it's going to create your whole architecture for you. When it's time to update your architecture, you can just run an update stack. CloudFormation is going to deal with, okay, I know that the architecture is in that state, and I need to get it to this state. I'm just going to do whatever I need to get it to that state. And if you ever need a new environment, and that's it. Thank you. Yeah, spoiler alert, indeed. If this is you, Abby, you're in so much trouble.
It's not.
Okay. So when a new environment is needed, you can just give it a different stack name, and you're going to get a whole separate environment brought up alongside. So really, really useful if you want to deploy infrastructure and architectures and then tear them down a minute later. When it comes to deploying these ECS resources, they're really, really simple in most cases to deploy with CloudFormation. So an ECR repository for storing your images. There's an example of the CLI here. And then we've got the CloudFormation. We just need to say what type is it. It's a repository, and give it a name. If you're using ECR, Container Registry, there's a nice little tip here. When you go to log in, ECR works with IAM permissions, so you get really granular permissions on your Container Registry. So like this development team can push images, that development team can pull images. One of the side effects of this is you need to log in before you can do a Docker pull. So there's a command here that I pulled from the AWS documentation that basically logs in and then pulls an image. To avoid you having to do this every single time you want to interact with ECR, there's a credential helper plugin on GitHub. There's actually a Docker plugin that will basically run this automatically for you behind the scenes, so then you can just do Docker pull. So it's just a handy little utility to have. Similar story for deploying your cluster. Again, you've got the CLI version on the left and CloudFormation on the right. Fairly straightforward. Where this gets a bit more complicated is when you actually start to think about the container instances that are going to run your containers. What I've got here is an architecture diagram for what a best practice ECS deployment looks like in terms of the container instances. So I'm going to walk through this a bit in a minute, but essentially we've got a VPC and a region as our outer box there, and then we've got 2 availability zones. So you may have 2, you may have 3, you may have 6. Whatever you choose in terms of your availability profile there. These availability zones are separate data centers, right? So each availability zone is 1 or more data center separated by low latency, normally under 2 milliseconds is the official terminology there. So we've got our availability zones, and then we've got public and private subnets, right? We probably don't want to put our containers directly onto the internet. We want some sort of middle tier. And in this case, we're using an application load balancer. We've got a few other bits in there. So let's cut this architecture diagram out a bit and step through it bit by bit, because it's a bit of a busy diagram there. So on the front end of our containers, we've got traffic coming in from our users. It comes in via the internet gateway on the VPC. And then in this case, we're using an application load balancer. So the ALB is a really, really nice way of getting traffic to containers with ECS. So it does path or host-based routing. So I can have one load balancer and say, okay, if anyone goes to /products, send it to that ECS service. If anyone comes to /customers, send it to that ECS service. And it will do that for you. So when a container comes up, it's going to automatically register it in the ALB for you. And if the container disappears, it's going to take it out of the load balancer for you. It's a very low-touch way of getting load balancing across your containers. The other thing we had on that diagram is the outbound traffic from your containers and container instances. So it may well be that your containers need to speak out to the internet. If they're in a private subnet, they haven't got a public IP address. There needs to be some sort of NATing through the public subnet. So in this case, we've got NAT gateways in our public subnets. And then the final bit is at the bottom here, logging. So you probably want some sort of centralized logging set up. So both for the logs on your instances and also your containers as well. Because if your pool of containers is coming and going constantly, you need some way of collecting those back so they're not lost when a container dies. So in this case, we're using CloudWatch logs, and we're going to dive into that in a bit more detail as we go through. So the too long I fell asleep while you were talking, Paul, version of this is all of this is provided for you as a reference architecture. There's a GitHub URL here, ECS Reference Architecture CloudFormation, where you can actually go to this GitHub page, click Launch Stack, and it's going to create you everything I just showed you with some example microservices. So at this point, let's actually do this. Let's go through, and let's deploy our first cluster. So ECS Reference Architecture CloudFormation. Okay, cool. So this is the repository I was mentioning a minute ago. In here, you'll find a whole load of CloudFormation templates. So if I go into infrastructure, for example, there's one that deploys the VPC, one that deploys the ECS cluster. So you can go in here, you can fork this repo, you can rip this stuff out and customize it if you want. And if we look down here, there's a couple of buttons, one for each region, that just allows you to really quickly deploy this. So if I go into London, for example, and launch a cluster there, just accept the defaults. I get to give my cluster a name, so I'm going to call this pre-production, and I think I may have one called that already, so we'll suffix it. And just accept the defaults. There's a tick box you have to tick here just to say this CloudFormation template is going to mess with IAM a bit. It's going to create some IAM roles. So you just need to accept that and have a look through if you're worried, and have a look through the IAM roles included within those templates. But you just need to give CloudFormation permission to create those roles. So if I look now, this cluster is going to come up. This takes about 7 to 8 minutes, so we're just going to sit in silence and watch, if that's okay, and I'll just check my Facebook. No, we're not going to do that. I've got one I prepared earlier. So you'll see this when you play around with this and deploy this. It takes about 6 or 7 minutes. You'll see the VPC being created, the cluster, et cetera, et cetera. And after around 10 minutes, if I go and look in another region where I deployed this previously, okay, this is what you'll see. So here, we've got a cluster. We've got the various different nested templates that create all the resources. And if I look at the outputs from the template, I can see a couple of example microservices. So in this case, there's a product service that's been deployed. And this is just a really simple JSON API, right, of products. The other microservice is a website. And this is the best website ever, I promise, that just lists these products, right? So really, really simple, but the example is there in the repo to show you how to get microservices to communicate with each other with the load balancer. So have a look in there, have a dig around and play with it. Feel free to fork it or submit back any changes you want to see in there. It's open source after all. Okay. Cool. So this point, nice. At this point, we've got a cluster up and running, or we will have in a few minutes anyway. At this point, we can start creating our applications and containerizing our applications and creating something real and tangible, deploying it. So that's what we're going to do. I'm going to Did you say turning mirroring on off would help? Basically, whatever it's not now, yeah? Okay, let's just try that quickly. Let's try that, see if that's any better. Hardware problem, is that what we're going with? It's a hardware problem. It's DNS. DNS over HDMI.
I'm actually just doing it so people will stay from my network.
Just keeps on cutting out whenever what's happening now? You've got USB there.
Okay, so we've got something there. So
Keep going.
play.
This getting. So now you're using 3 different things through this, and the same cable.
Yeah.
I have another one of these though.
Yeah, let's grab the other one and see. Just make sure it's not the connection down here. Okay, what I might just do is not put this into presentation mode. Let's leave it like this for the minute, and if it does it again, I'll switch dongles.
It's going quite hot sort of thing, so maybe it's that, I don't know.
Could be. We'll see how it goes. Okay, so what we're going to build is a Twitter analysis bot. This is going to subscribe to a Twitter search stream, and it's going to collect tweets in a microservice called Tweet Collector. Tweet Collector is a simple service that subscribes to the Twitter API, receives tweets, and then forwards them on to another service called the Tweet Archiver. Now, the Tweet Collector needs a few things. It needs to know my Twitter API credentials. And believe it or not, I wasn't very comfortable putting those on screen for everyone to see. And as per best practices, I probably don't want to bake them into my container either. So the AWS SSM parameter store is a really, really nice place to store container secrets and configuration data. It's hidden away in the EC2 console. If you go into the EC2 page, it's near the bottom, parameter store. But it's a simple API that allows you to put configuration data in and get configuration data back out, and optionally encrypt it with a KMS key of your choice. So then you can define with IAM policies who and which containers can actually read and decrypt those secrets. So it's a really, really nice way of doing secrets for anything from serverless, containers, EC2, et cetera, et cetera. So top tip there. So tweets are then going to go into the tweet archiver, and then we're going to use Kinesis Firehose to actually archive these tweets to S3. Maybe I want to train some sort of machine learning model later down the line. I want to have an archive of these tweets. And maybe I want to use something like Elasticsearch to do analysis and graphing of these tweets. And maybe I'm going to tie into Lambda as well and do real-time alerts and notifications, et cetera. So this is my basic architecture. I actually did the classic bad developer thing of finding a new technology and then thinking of something I could develop to play with the new technology. So this architecture uses for communication between containers and between our microservices. A library that was released recently by Twitch. Did anyone see this? It's quite interesting. Who here's heard of gRPC? Okay, a fair few people. So gRPC is a way of communicating between services without using REST. So using binary protocols and using something like protobufs to actually define your contracts between your microservices. So it makes for quite a nice way of communicating between microservices, much lighter weight than traditional REST and HTTP, HTTPS. But there's a couple of downsides with gRPC. The first is it's pretty heavyweight. It has a lot of features and functionality, and most people don't need all of them. It's also not compatible with HTTP 1, which means you can't use it behind any of the AWS load balancers. It needs HTTP 2 for gRPC. And our load balancers don't support HTTP 2 through to the back end.
Application load balancer does.
Sorry?
Application load balancer does.
No, application load balancer supports HTTP 2 from the browser to the load balancer, but not back to the origin, to my knowledge. Okay. That must be pretty new then, since I last checked. Okay. So Twitch released an open source library that they've been using for quite a while to do microservice communication. And it solves a lot of these challenges. So it works with protobufs, but if you just want to diagnose and debug and troubleshoot your microservices, you probably don't want to use protobufs, which is a binary protocol. You probably want to use JSON instead. So Twitch's library, twerp, actually supports JSON as well, so you can use your normal tooling. So we're going to use this for communication between our microservices, but you could just as easily use REST if you wanted to. So the way Twitch's library works, I really struggle saying Twitch twerp. The way Twitch's library works is you define a protobuf definition. So in this case, we've got a service called Twitter Archive, and it's got one RPC method called create. And it takes a create request and returns a create response. And those messages are defined down here. So when we create a new message to the Twitter archiver, we're providing a name, so who did the tweet, and the actual message of the tweet as well. So from this definition, the Twitch library will generate for you automatically all the code needed to run a server and also a client library as well. So it will generate the clients for you. So to look at these two microservices, the tweet collector that actually gets the tweets from Twitter, it uses the Twitter API, as I mentioned. We want to be able to configure this at runtime. We don't want to bake in configuration parameters into our containers, right? We want to follow the 12-factor application patterns and pass stuff in via environment variables. So in this case, I'm passing in a couple of configuration items, so the search terms to search Twitter for, and also the archive HTTP endpoint for the other service. We're going to give it an IAM role. So ECS allows you to assign IAM roles to individual tasks and containers. So you can actually scope down your IAM permissions to the specific services. And then it's going to forward on tweets to the other service using the auto-generated SDK. So on the other side of it, the archiver service, this hosts the RPC server. It's going to send tweets onto Amazon Kinesis after it does some filtering and maybe some modifications. And again, it's configured with an environment variable just telling it which Kinesis stream should it put those tweets on. And we're going to give this an IAM role that can mean it can write to Kinesis, and then it responds with the Kinesis sequence number or an error. So what's my development workflow going to look like this? How should I actually develop this? And there's a couple of different options and different ways of doing this. The way I've got comfortable and used to doing is when I'm running locally and developing locally, use Docker Compose. Right? It's part of Docker. It allows you to have your containers, specify them in a Docker Compose file, and very easily bring it up and down on your laptop. Things like logs are going to be sent to your laptop standard out and standard error, so really easy to diagnose while you're debugging and developing. And also it's going to make use of things like your local AWS credentials, and it allows you to push and build containers into your registry. I'm not going to use a CI/CD pipeline in this example, but that would probably be the next step after doing this. On the AWS side, when we deploy it, I'm actually going to use CloudFormation to deploy this. So much like we did with our actual infrastructure earlier, we're going to deploy our task definitions and container definitions with CloudFormation. We're going to centralize our logs in CloudTrail, and we're going to use IAM task roles to assign those IAM permissions to the containers. So this is all open source, this whole RPC project. You can go onto GitHub and have a look. It's just on my personal GitHub, but there's the archiver and collector service, and you can go in there and have a look. So feel free to have a play with this afterwards. So let's go in and actually look at how we'd develop this locally and how we'd deploy it. So I've got my actual services here. If I look at my folder layout, for example, I've got the archiver and collector services. I'm not going to go too deep on these because it's kind of just basically auto-generated code, a lot of it from that Twitter model. But you can see we've got the same Twitter model here that I showed earlier. Then we've got a Go application that actually runs that Twitter twerp server. So within each of my microservices here, I've got a Docker file. And in this case, I'm using the standard Go Docker image that's published to Docker Hub. It's probably not best practice with Go. Like one of the nice benefits of Go is that it builds static binaries. They're normally very small, a couple of megabytes in most cases. Whereas with this, it's got a whole operating system and actually compiles my application, and the resulting Docker image is a couple of hundred megs. So fine for testing, playing around, debugging. Production, you'd probably want to start from scratch or something and use a different method. So I got my Docker file in each of my microservices here. I've got a Docker compose file. And in this compose file, I define my two containers. So I say, OK, I've got my collector service and I've got my archiver service. And the build parameter in here is just going to tell Docker Compose, when I run it with -- build, to actually go into that directory and build using the Docker file that's in that directory. When I push it to that location. And that long URL there is an ECR registry URL. And then I define my environment variables. So in this case, my search term that I want to subscribe to and actually follow all the tweets, I put Amazon. This took me quite a while to find a search term that I felt comfortable showing on screen in front of a whole load of people where I could potentially lose my job. So caveat, if while I'm demoing this, something absolutely horrific comes up on screen, please don't tell my manager. I like my job. And then configure the other parameters there. And then we've got the same similar story for the archiver service below. So one of the nice things about Docker Compose is it makes network communication between services really, really easy. So my containers have got name archiver and collector. And actually, I can just use those as host names. So within my application, I can just talk to collector as a DNS name. And Docker Compose is going to set that up for me automatically. So if I open up a terminal now, is that big enough at the back? Ish. So I'm in my directory. If I run Docker Compose up, it's going to bring up my two services, and they're going to run, and it's going to subscribe to a whole load of tweets and output the tweets, and I'm going to stop that before it shows something highly inappropriate, because Twitter is like that. So these are my services up and running. You can see I've got messages coming from my archiver service, and I've got my collector running as well. My two microservices are talking together locally. So I can now continue, develop, iterate, and work on my services locally, and just run them in Docker Compose whenever I want to run them. So the other thing I can do is push, and actually push these up to ECS. I need to authenticate using that command line I showed you earlier, because I haven't got that helpful plugin installed. But this will allow you straight from Docker Compose just to push up to ECR when you're ready. So the flip side of this now is actually getting this running within AWS. So for this, I'm using CloudFormation. So here I've got a CloudFormation template. And this is copied from the repository I showed you earlier, the reference architecture that comes with the two sample microservices. You can actually rip the one straight out of there and just add in your image. So in this case, I've got an ECS service, and I've got my task definition that's got my containers in. So this is very similar to the Docker Compose file, and I pass in things like environment variables in here, etc. I set up some centralized logging. So one of the cool things about using ECS is it's got really tight integration with CloudWatch logs. So CloudWatch logs, just by specifying some log configuration here, so a log group and a region to send my logs to, I can automatically get all of my logs aggregated from all of my containers, standard out and standard error, into CloudWatch logs. So in order to deploy this, I could just run AWS CloudFormation create stack, give it a stack name, so production tweets in this case, and then pass in my template file. So that's going to go away, and that's going to start creating my stack and deploying it onto AWS. If I go and look in here now, within CloudFormation, okay, I can see my services started creating. If I look at the resources that CloudFormation is working on, I can see, okay, it's created my centralized logging group, it's created a Kinesis stream for me, and very shortly that will actually start deploying the ECS services as well. So if I go away and look in ECS, for example, I can see here I've got my production cluster that we deployed with CloudFormation, and at the moment the service hasn't appeared. There we go. So we've got our production tweet service now. We can see there's a desired task of 1. So what this is doing right now is pulling that container image from ECR. So as I mentioned, it's a couple of hundred megs. It's going to take a few seconds there just to pull that. And what we'll be able to see is, if we go in and look at the tasks, you can see we've got one task pending. And shortly that's going to pull the container image and it will be up and running. So let's give that a second. If I go into CloudWatch and look at the CloudWatch logs section and search for production. Okay, so because I set up the centralized logging within my AWS account, within the task definition, I can now go into production tweets as a log group and have a look and see, okay, the actual logs from my container. So I can see the archiver service. And you get the same experience as Docker Compose locally. I can go and look at all the containers across all my hosts as they scale out and scale in and actually see the logs. Can't believe no one tried to get a tweet up there cheekily. So before we continue any further, who here knows what metric filters are in CloudWatch logs? A couple of people. This is a service, a part of CloudWatch logs that we don't really talk enough about, I think. It provides a really, really nice way to create alarms and graphs and programmatic events that fire when something in CloudWatch logs happens. So as an application developer or ops person, I probably want to know if my containers output anything with the word error, right? And I want to be alerted on that, and I want to be able to visually track that in a graph. So within CloudWatch logs, you can do that by setting up a metric filter. So if I take my production tweets log group, so all of my microservices, create a metric filter here, I could search for the word error or just error. I can test that, and at the moment, okay, out of a sample of 50 events out of my log, there are no lines mentioning error. Good, cool, but at some point there might be. So I can then give this metric a name, errors in tweets, and create that. I can then go and create CloudWatch alarms based on that. So maybe I want to trigger, a hook into a Nagios system or Prometheus system or something that I'm running somewhere else. Or maybe I want to email someone and alert someone whenever something like that happens. The other thing you can do is, if I just load this up here, this is a graph that shows all of the incoming requests to our Twitter service. And you can see where shortly earlier this morning I actually killed it before the demo. But there's some previous historic logs there. If any errors appear in here, right, because I created that metric, they're going to appear in here, they're going to be automatically graphed for me, I can actually go and click this little page icon up here and view logs in the time range. So I could select the specific time period where the error occurred, and then straight away go straight down and see the container logs at that particular time across all the containers in my architecture. So really, really nice, easy way of setting up programmatic alerts and diving quickly into the relevant area of the logs. Okay. Oh no, I've just put this in full screen. We'll see how this goes. So next steps here. We've created this service. It's up and running. It's collecting tweets. Next steps are probably to do things like integrate with Kinesis, or maybe you want to build a dashboard to show various search terms, etc., and build graphs, etc. The good news is you don't have to do any of that because we've made it for you, and you just need to click a button and it's going to deploy for you. So there's a blog post that we published recently, URL there, slides are going to be shared, that has a CloudFormation template that you can actually deploy this straight away and start analyzing tweets. It's a good use case for machine learning here. They use it to try and predict patterns, etc. Okay, so we've got our service up and running. We've thrown it into ECS. ECS is now running it. It's a long-running service, so it's automatically going to be restarted if it fails, self-healing architecture, etc., etc. What are the other things that we need for production? Cost optimization. We haven't talked about cost at all yet. So I've got my service. I know I probably want to be running it all the time, right? Okay, because I want it to be collecting tweets all the time. What's the best way of optimizing costs there? So if you're deploying with ECS onto EC2 instances, there's a couple of options available for you. Because they're just EC2 instances, you can take advantage of some of the pricing mechanisms that come with EC2. So things like reserved instances. So RIs, reserved instances, allow you to tell us, hey, Amazon, I'm probably going to want that instance for a year or 3 years. in return, we'll give you a cost saving by committing to that. It helps us plan. So these are RIs. Really good strategy here is to reserve your baseline capacity. So if I know that on any normal day I get an average of 5 instances I need running my containers, but actually I have peaks and troughs, I could reserve those 5 instances full time, and then when I peak up, I can just use on-demand pricing for that. Another really cool way of saving costs is to use Spot Fleet. So Spot is a way of you bidding on unused capacity in our data center. Okay, so you can get really, really good cost savings by doing this, up to about 90, 95% in some cases. And basically, you're bidding on that unused capacity, and you set your bid price, and we have a price that we think is like the market demand price for that particular instance type or family. And if your bid price is above our market price, you get that instance. The flip side of that is we could take that instance away. If there's a run in our availability zones or regions for a particular instance type, and the price shoots up, that could go above your bid price. When that happens, you're going to get 2 minutes warning, and then we're going to take the instance away. So you need to bear this in mind. It's not suitable for all use cases. If you have transient workloads, batch workloads, dev, test workloads, it's going to save you a lot of money. For production workloads, there are things you can do to minimize the risk of losing your instances. Like normally with Spot, you basically bid on an instance type, so C4 large, and you bid on it in a particular AZ. That's not a very diverse bidding strategy. There's something called Spot Fleet in AWS that integrates well with ECS as well, where you basically say, I don't really care what availability zone. I don't really care what instance family or type AWS. I just want this much CPU or this much memory, and I want it spread out as much as possible. So this is a really nice way of diversifying your bid, greatly reducing the risk of losing those instances. And I've got customers in financial services that run production workloads with ECS on Spot, but it is an individual risk conversation for you to think about. So ECS clusters within AWS are really, really easy to create, right? It's one command normally. You can have those clusters up and running. So don't limit yourself to just one cluster. It's really common to have like a prod cluster and a non-prod cluster. Maybe you have PCI certified workloads for handling with credit cards, and you want to minimize the scope of any PCI audit, so you want to have a separate cluster that runs your PCI workloads. Again, a common use case. They can use different pricing strategies as well. So you could have a dev cluster that uses Spot Fleet, a production cluster that uses reserved instances and flows into on-demand for those peaks. And maybe you've got a batch processing cluster that takes advantage of GPUs or something, for example. You can have that as a separate cluster as well. So don't limit yourself to just one cluster. Let's talk a bit about scaling. When we deployed, we didn't actually define any scaling properties for our services. There's 2 ways of auto-scaling with ECS. The first is the container instances. Again, if you're using Fargate, you don't need to worry about this. But if you're using EC2, you're probably going to want to scale in and out that pool of compute. So auto-scaling applies here, right? You can use normal EC2 auto-scaling. These are just EC2 instances. So you can scale in and out. A really good metric here is the memory reservation metric for ECS. So how much memory have I reserved for my containers, for my tasks, and scale in and out based on that metric. That's a good one that a lot of customers use successfully. The other scaling mechanism is application auto-scaling. And this is at the container level, not the host level. So yeah, your pool of compute may scale in and out automatically, but maybe you've got a scenario where you have an Nginx container, for example, and you know that that Nginx container can handle 30,000 connections a second, like arbitrary number. You probably want to scale in and out the number of Nginx containers you're running based on the incoming connection rate. So that's where the application auto-scaling comes in. So when you deploy a service into ECS, you can set up your auto-scaling there. And again, you can choose which metric you want to scale based on. So you can scale on CPU or memory usage or even a custom metric like number of sales made per second or something. All these are possible options. This one I can't give you an easy go-to recommendation for what your scaling metric can be. This one is going to be very specific to your applications and workloads. Okay, next, security. Haven't spoken much about security either yet. Let's talk through some options around best practices when it comes to security. So the first thing that a lot of people ask me is, okay, we've deployed our ECS instances now. How do we patch them? How do we do that without any downtime? If you're using the CloudFormation reference architecture I shared earlier, or CloudFormation or Terraform, for example, this is pretty easy. Within CloudFormation, there's something called an auto-scaling rolling update policy. There. An auto-scaling rolling update policy within your CloudFormation template is going to tell it, don't take down all my instances at once. Do it in a rolling fashion. So what we've got in this case is a CloudFormation template with an AMI. And this is the idea of the base operating system. And if we ever want to change that, if we add in this update policy to our template as well, the auto-scaling group is automatically going to take down one instance at a time, or whatever speed you choose to do this at. You can take down one, upgrade it, make sure it comes back online all right, and then move on to the next one. So this is a really, really easy way of rolling out those automated updates with zero downtime across your fleet of EC2 instances. The other side to security with containers is what actually happens inside the containers. I mentioned earlier this is one area that I don't actually get asked about enough, which worries me. So what's going on inside your containers? So with containers, it often worries security teams. There's a perception of lack of visibility, right? Maybe you're used to operating systems and AMIs and antivirus, et cetera, and you have predefined security policies around those in place. To a security person, a container can look like this opaque shipping container that they lose visibility with. There's some really nice options out there in the market for actually solving this problem. It's not something that you need to reinvent yourself in most cases. So the two main players in this market that I'm aware of are Twistlock, who I'm showing up on screen here, and also Aqua Security. And both of these companies have products that sit in your CI/CD pipeline. So when a developer commits a new Docker file, it will actually go away and it will build that image and it will do a vulnerability scan on that image and look at all the packages held within that image, within the operating system, et cetera, within your container image, look for things like CVE vulnerabilities, et cetera, and actually reject it in the pipeline if there's any vulnerabilities. You can set your risk threshold, et cetera, there. So this is a really nice way of making sure nothing sneaks into production. And if you've got security teams in your organization that are worried about containers, or maybe you're the security guy and you're here because you're worried about containers, solutions like Twistlock and Aqua are really, really nice ways of attacking this problem. Another top security tip is to minimize the surface attack area within your containers. So this is something that I didn't pay respect to when I built my demo earlier and I had my 300 or 400 meg container. Wherever possible, try and keep your containers as small as possible. So within Docker, you have the Scratch container. This is a really good option if you're building Go applications, by the way. Go builds like near static binaries, so you don't actually need a full operating system in your container just to run a Go binary. So building from the Scratch container is great in many cases, or just trying to minimize that attack surface in general. Last slide on security is IAM roles, permissions. Do not bake AWS credentials into your containers ever. Full stop, period. Don't do that. There are better options. So IAM roles. IAM roles have existed within EC2 for a long time. They allow you to assign IAM permissions to an EC2 instance. You can do that with ECS. You can do it at an instance level. The downside to that is any container that runs on that instance is going to get those same permissions. So there are times when you might want that to happen. Things like maybe some sort of logging solution or some sort of monitoring solution. Every container on the host should have those same permissions. Most of the time, though, you actually want to scope those IAM roles more granular, down to an individual container or task. And this is where you select the IAM role per task. So this is an option in your task definition JSON file or in the UI when you deploy your container via the AWS Management Console. So make sure you're using these. Don't bake credentials in, ideally not even with environment variables. This is a nicer solution. Finally, monitoring and logging. Built into ECS, you have built-in monitoring. So it integrates with CloudWatch, and you're going to get graphs for things like CPU and memory utilization on your ECS cluster and hosts. So really, really useful. You don't need to do anything to get that up and running. It's there by default. And you can dig a bit deeper as well and look at things like load balancers and see what's my average latency for this service, or how many 500 errors am I getting, and dive in. I showed you earlier how you can dig in specifically to log items as well from here. If you don't want to use CloudWatch, that's cool. There are other options out there as well. Maybe you're running something like Prometheus already. There's a handy plugin for Prometheus that someone wrote that actually exports all of your ECS metrics straight to Prometheus. So if you're using Prometheus, this is a nice option. I mentioned centralized logging. You get this just by adding these lines to your task definition. I mentioned it with CloudWatch using the AWS Logs Docker plugin. There are other options there as well. So things like syslog, FluentD, Splunk, Gelf, etc., all common options, and you can just switch out the definition in the task definition. So instead of using AWS Logs for CloudWatch, you can actually use Docker's built-in plugins for those other logging solutions. So when you use the AWS Logs one, it's going to pull all those logs back centrally, like I showed you in the console a minute. And metric filters are the key bit that allow you to take log items and turn them into alerts, searches, and filters and alarms. So I've kind of blatted through a whole load of different best practices, everything at like 1,000,000 miles an hour. And you, like, if you're like me, when you're watching these talks, you'll probably take away 10% of it. If you're going to take away anything from this talk, make it this slide. This is the one you want to take a picture of. This is the one that you want to look at. There's a GitHub repository created by one of our developer advocates, Nathan Peck. It's called Awesome ECS. It contains everything about everything you need to know about containers and ECS and containers on AWS. So in that repo, in the README, there's loads of sections like how to do service meshes, service discovery, how to do blue-green deployments versus rolling deployments, etc. This is a really, really useful GitHub repository. And if there's anything that I mentioned during this talk and you find yourself like a month later thinking, what was that thing that guy from AWS was talking about? Chances are it's all on this page. So at this point, I'm going to hand over to Q&A and give you a chance to ask any question you want about ECS, and I'll try and answer it. Have you got the microphone, Abby? Or?
I do. Are people raising their hands yet?
This is your moment.
It's my moment. I'm ready.
I'm on the wires. Any questions?
Does anyone have a question for Paul? Back of the room.
Right at the back.
Whew, gotta get my work done. Okay, well, this is impossible.
You talked about VPC networking earlier
Yes.
for container. So is that available for ECS?
Yes, it is. So one of the networking modes in ECS, you have bridge networking mode, which will use the Docker bridge. You have host networking mode, which will just map ports onto the instance host. You have none, which is no network for your container. The other one and the new one is AWS VPC. That's the term to search for on Google. With that, every task that comes up is going to get its own native IP address within the VPC, and you'll find they can just communicate, right? There's no overlay network, no encapsulation, etc. So yeah, that's absolutely an option there.
Right. So does it need to remember the port of the host? So like for each of my container, does it need to attach a specific port?
No, that's a really good question. So in terms of the host, when it creates the ENI for your task definition, your ports will be mapped onto that. So if I have a container for Nginx that listens on port 80, that single IP address for my task, port 80 is going to be that container. If I have other containers, they're all going to map onto that single ENI IP address. And what you'll find is that if you want to communicate between containers in a task definition, they can all just use that local host or that ENI address, and they can communicate between each other. So it gets away from that scenario where you can't run multiple versions of the same thing on port 80 on the same host. You don't need to worry about that with the AWS VPC networking mode.
Nice. And are they available on Windows container as well?
Pass. I'd need to check. Find me afterwards, and we can check the documentation.
Okay. Thank you.
There's a question at the front, Abby, just so that you get your full workout today.
By the way, we're going to cover possibly exhaustively networking in the Fargate one because I love a good networking conversation. So.
Hi, thanks. Is it possible to pre-bake your image for the container and deliver it through Service Catalog to our devs?
Yeah, so I don't need to repeat the question, you've got a microphone. So yes, you can. So your ECS container instances that run the actual containers, you can actually bake containers into the AMI, and it just means that Docker's not going to have to pull it from your registry when it starts up. That can be a lot of overhead, though. It's not a way of working that I'd normally recommend. Simply because whenever you need to change your version of any of your containers, you're going to have to bake another AMI and publish it, etc., and roll your cluster, and it's going to add to quite a bit of overhead. Docker itself will cache the image, so the first time it pulls that version of the image, it's going to be cached locally on the ECS instance, so any further pulls of that same version with the same SHA hash are not going to pull over the network again. So there is some caching there. Ultimately, if you need super fast scaling, and you've got super large container images, you may take that route.
No, it's more baking in compliance so that the devs don't do bad things.
Okay, so I would normally recommend fixing that in your CI/CD pipeline. So getting automated in checks in place there to give feedback earlier than deployment back to developers. So using things like Twistlock, if you're using CloudFormation, using things like CFN NAG, which is a CloudFormation static analysis plugin that's available on GitHub. Using those sort of tools to get into the CI/CD pipeline, just to reduce that feedback loop. If a developer's got to wait until it's all the way and nearly at production before they receive that, then they probably switch context. So wherever possible, try not to do it that late, but happy to dive a bit deeper on specifics if you want to chat about specific requirements there.
Can we just, while creating the service container, let's say we create the container, can we just specify the exact port rather than the dynamic port?
Yeah, so when you specify in your task definition the ports for each container, normally you specify it with a host port and a container port. When you're using the VPC networking mode, you don't need to specify the host port, you just specify the container port. When you're using the application load balancer, you don't need to specify the host port. You can just let it automatically generate one for you, and the application load balancer is going to know, and it's going to map that through for you automatically. The only time when you need to actually specify the host port is when you're using like host networking mode or bridge mode, and you want to actually not use the application load balancer, or you're not using the AWS VPC mode.
ELB or NLB, though, you can specify. If you don't want the dynamic port allocation, you can specify. But generally, that's behavior that I want my application to use because it removes a resource constraint.
Yeah.
Okay, next one, it's a real case kind of problem which I'm facing. Normally, container fire up on the Docker Compose kind of things. When I just try to deploy it, right, there is a problem. But the problem is not on the operating system level. The problem is on the application level. Let's say on my case, I know I just specify 64, right? We just need more than that. And it took some kind of it took quite a long time to figure out that problem. Is there any way which we can diagnose easily?
So if you deploy a container into ECS and for whatever reason it fails to start due to a configuration error or something, ECS is going to keep retrying to bring that container up, etc.
That's the problem, because in order to diagnose, I need to log on, right?
So the answers to that are centralized logging, so that you're not going in and having to introspect each container and try and work out. Get the logs centralized back to a central place that you can diagnose through logging that way. But also the ECS console gives you a whole load of debugging information. If you go into the individual task in the ECS console through the web UI, you can see reasons on why it failed to start. I mean, you can use a CLI as well to get that information. But
I'm talking about the application let's say port 80 is open, which is working perfectly fine. But inside that container, I have something, right, which is failing inside that container itself.
Yep.
And at that time, you will have the problem. So is there any way to diagnose?
Centralized logging would be my main recommendation there. But you can also try, for example, if you're running on EC2, you can just SSH into the hosts, and you can inspect a running Docker container there with the normal Docker CLI tooling there.
Potentially unpopular opinion here, though, but if you're running into a problem where it's passing health checks, but your application is messed up, I generally feel like that's something that should have been diagnosed earlier in the local process because it's preventing your application from functioning. So that's something that it sounds like maybe you need tests earlier in the process to catch an error like that so that you're not in a situation where you're trying to SSH into a production host to diagnose something. So it sounds like a case for more unit and integration tests earlier on in the development process.
It's like it's working perfectly fine on the test level, right? When we try to deploy it,
Yeah, I think it's a common problem is works on my machine, and then you need a local environment that matches more closely your production environment so that you can debug where that issue's coming from.
Okay, thank you everyone.
It's lunchtime.